All right, so we were right here talking about the tilt of the Earth with respect to the ecliptic. Remember, the ecliptic extends from the center of the sun and extends out into space. Well, this is the Earth, of course, but um, so there's this tilt that accounts for the seasons. All right, let's move on. Does the Earth actually rotate? That was a question that the Greeks had, and it actually wasn't shown experimentally until less than 200 years ago by what's called the Foucault pendulum. And the Foucault pendulum, this is not a good representation of it, um, because for you to notice this, the pendulum has to be much larger, much longer. You have to these things to actually see a Foucault pendulum. If you've ever went to like a science museum, they generally have these where it's a multi-storied building, and the pendulum is, you know, um, more than 50 feet long, and sometimes they'll have sand coming out of the pendulum, so that what you see is, as the pendulum oscillates back and forth, uh, because of this effect, the fact that the Earth is rotating, there's this effect called the Coriolis effect, and basically the plane of oscillation, the plane of the pendulum, will turn. Okay, and that was observed, like I said, little less than 200 years ago, by this guy named Foucault, um, and that proves without a doubt that the Earth does rotate. So the Greeks, even though they didn't believe that the Earth rotated, this is something that you don't notice the Earth rotating. It doesn't feel like it's rotating. So we can kind of forgive them a little bit for that. And like I said, this experiment is very recent in human history. All right, so the precession, this is what I mentioned before, the fact that the Earth is slowing down over time. It's a very slow process. It's slowing down. This is basically what happens every 100 years. The Earth's rotation rate is slowing down by about 0.002 seconds. That's 0.002 seconds per century. And so because that's happening, we have this precession. Just like a top, if you've ever spun a top, as it slows down, it wobbles. And so that's what's happening with the Earth. One thing to note about that, though, is that the pole star. I mean, these are some results of this very long precession. Over time, the pole star, what we now, the star that's called Polaris, that the northern, if you extend the North Pole, a line from the North Pole out into space, there happens to be a bright star that people can see, called Polaris, but that won't always be the case. 13,000 years from now, it will point towards another very bright star in the northern sky, called Vega, in fact. Another phenomena about this that people usually get a little upset about when they find out about this is that the position of the they're actually showing that. Oh, there we go. This is what I was just mentioning. Here's Polaris, and then in the year 14,000 A.D., if humans are still around, a Vega, which is even brighter than the current North Star, will be the North Star. Now there won't always be a star. These are just two stars that are particularly bright to the human eye that we can see. So you won't always have a North Star. In fact, in the southern hemisphere, there is none. There is none. No really bright star to point to the southern pole, that we can see with the naked eye. All right. So anyhow, the other thing that I was mentioning is the positions of the constellations of the zodiac will change, and so back during the time of the Greeks, for example, the spring equinox, right? It's also known as the vernal equinox, just like the fall equinox in September is also known as the autumnal equinox. Anyhow, they they actually wander through the constellations of the zodiac. So back during the time of the Greeks, the sun was in the constellation Aries. Currently, 2,500 years and something years later, the sun is in the constellation Pisces for the during the spring equinox. And that's going to change in the future. It'll be in the constellation Aquarius, and then after that, so very slowly it'll wander throughout all the constellations. And all right, let's see the place and time there. Oh yeah, of course. So how do we measure time? The ancients, of course, just used the rotation of the Earth and a sundial, or the apparent spinning of the whole sky. They didn't accept that the Earth moved, but anyhow. Oh yeah, what about figuring out where we are on the Earth, right? Of course, the Earth is circular, so what we need a different method than something that reflects like just a flat object. So what we do, of course, let's go back. What we do is we use. Let me get back to the right spot. We use these lines, these parallel lines of latitude, right? So the lines north and south are called lines, are your latitude. And for example, we're about in South Carolina we're about 35 degrees north of the equator. So you measure it either north of the equator or south of the equator, where the North Pole would be at 90 degrees, the South Pole would be at 90 degrees. Okay, and there it's shown. So there's 20 and 30 would be somewhere here, and we're slightly north of that. Well, 35 degrees. All right, and then how do we identify our positions? East and west, and so just like we use the equator as a reference, there is a line called the prime meridian, which because England was in power when this was established, Britannia ruled the sea, as it were, back many hundreds of years ago. Anyhow, this prime meridian passes through part of England, and in fact, it goes right through an observatory that was built. All right. So anyhow, that's the prime meridian, and we are a certain number, or you measure points to a certain number of degrees, either west or east of the prime meridian. For example, here in Rock Hill, South Carolina, we're at about 81 degrees west of the prime meridian. And just to let you know, I mean, you could always tell your latitude, and so these are longitudinal lines. You could always tell your latitude by observations of either the sun or the stars. So you could always tell how far north or south you were, if you think about traveling in a ship, but your longitude was much more difficult, and until really accurate timepieces were designed, and timepieces that could really handle sea travel, because you're oscillating back and forth, and you're also pitching. The ship pitches up and down, and so you have to have a very accurate timepiece. That was the way when that was made. You could much more accurately tell how far you'd gone, either east or west. All right, longitudinally. Okay, so of course, we talk about the intersections of your Latin long, your latitude and longitude. Okay, let's move on here. Yes, yes. Of course. Okay, so there are latitude lines that are particularly interesting. Of course, the equator at 0. 23.5 degrees north of the equator, they call it the Tropic of Cancer. 23.5 degrees south of the equator, that's the Tropic of Capricorn. By the way, remember the whole thing I just mentioned about the precession, right? So back during the time of the Greeks, when these things were named, the sun was in, so there's a particular day of the year that the sun is directly overhead, for the Tropic of Cancer, and so that when literally at 90 degrees, straight up, so you look straight up on that day, and the sun is at 90 degrees with respect to the horizon, so it's directly overhead. If you put a stick straight up and down in the ground, it would cast no shadow, and so of course that's the summer solstice. That's when that happens. When the sun is directly over the equator, of course, that happens 2 times a year, and those 2 times are the equinoxes, right? So when the sun is directly over the equator, you have equal amounts of day and night, and all right, and then we have, of course, when the sun is directly over the Tropic of Capricorn, then that of course is the first day of summer for the southern hemisphere. That would be the first day of winter for the northern hemisphere, and so then the sun just keeps oscillating back and forth. It takes a whole year to go all the way back. So this would be June 21st, and then the sun would be just going forward in time. This would be September 21st, and then December 21st, and then back to March 1st. So that would be going from, as far as the northern hemisphere would be concerned, when the sun is directly overhead here, that is the first day of summer, and then of course the first day of fall, the first day of winter, the first day of spring, and then back to the first day of summer again. These actually should, where the sun is no longer in the constellation Cancer. It's actually in Gemini now, and this should not be called the Tropic of. I mean, it's not going to change. The names aren't going to change. They've been around for thousands of years, but it should not be called the Tropic of Capricorn. The sun isn't in Capricorn when this happens. It's actually in Sagittarius. Okay, so all right. Let's see. Measuring time. Let's see. I think I'm going to leave this for the next video. All right.